Class, how are you doing? We talked about conic sections. First of all, if you take the surface area of that one, you call it nap. This one has a surface area, this one has a surface area, therefore this is called upper nap, lower nap, therefore this is called double napped cone. The double napped cone was generated by the fixed line right here, and this one was this one was a rotating line. You take this line and rotate it around that fixed line, and thus you get a double napped cone. If you take that plane, this is a plane, and the angle the plane make with that fixed line become greater than that angle, therefore that plane only passes through this cone, upper napped or lower napped. It depends which one you send the plane through. Therefore, because you're going once, the cross section is going to be an ellipse. And if that angle is greater, the maximum it can get is 90 degrees. And if that angle become 90 degrees, it becomes a circle. Every circle is an ellipse, but every ellipse is not a circle. Therefore, circle itself is a special kind of an ellipse. But somebody said, what happens if that angle of the vertex become equal to that angle? Well, in order to be equal, this line and this line must be parallel. Therefore, if these lines are parallel, this is called transversal, and these are the same. Therefore, if it become parallel, still this line will not go through the double napped cone. Therefore, you only have one branch, and it produces a parabola. But if the angle become less, means that angle become less, therefore that plane gonna go through both of those cones. And it produces a parabola on the top, parabola on the bottom, but these are called hyperbola. And it will come through both cones or double napped cone and produces a hyperbola. And a hyperbola had two distinct branches. We prove the definition of a parabola, they prove the definition of a hyperbola, ellipse, and how those the formula represented the relationship between x and a y. Here I'm going to find the relationship between x and a y too. Therefore, I'm going to draw me a circle. And remember, on the parabola, we use the line as a directrix. On the ellipse also, we use the line. But in here, for ellipse, I use a circle. But where was the circle? The circle, I pick a point inside the circle. This time, I'm going to pick a point outside the circle. Therefore, for ellipse, I put a point inside. For the hyperbola, I'm going to put a point outside. For a parabola, it was a line. Then I'm going to pick 1,000,000 points on my directrix. 1,000,000 points. And with all those points, I'm going to connect them to the point outside the circle. And I'm going to find midpoint of it, which is called perpendicular bisector. Then I'm going to go to the point on my directrix, which is on the circle, and I'm going to draw a line that it passes through the center of a circle and here. And I'm going to say, does this perpendicular bisector intersect that line? I said, yes, it does intersect. Where? Right here. Therefore, I'm going to find the point of intersection, and the point of intersection is right here. And I'm going to do the same thing for every other points on the circle. I'm going to do the same thing. Connect it to the point of C, draw a line through A, and see where these two lines intersect. I'm going to do for all of them. And then I'm going to study that point of intersection. I'm going to say, what is the point? Where is the point of intersection of the perpendicular bisector and the line through this origin, the center of a circle, and through my point? Where is located in XY plane? In XY plane is located right here. It depends where I put my center of a circle. If I put on the center of a circle, this one is in the second quadrant. By moving that point, it come to fourth quadrant. What happened if I trace that point of intersection? See, I already did it. I traced it, and I'm going to say put a trace on each of these quadrants and mark the quadrant. And when I do that, let's what happened for every one of those points around the circle. God, what did I get? I get two distinct branches. Two distinct branches. And this is called hyperbola. I'm part of the conic section. Therefore, I traced that one, and I said, what is going to be on those? By moving these points, and I get my hyperbola. Okay. Then do me a favor. Tell me where is point E. The point E could be at one of these branches at any given time. See, it's going to be in this branch right now. It's going to stay in that branch, in that branch, in that branch, go to infinity, come back and start from negative infinity and go back to infinity. And that's going to travel in one of those branches. I'm going to say, okay, what happened if that point is in that branch? And tell me how far is that point from that point outside the circle? Well, I have to find that distance. And that distance is 6.03. Let me make my circle larger and see if I can make that 6.3. I really want to make it smaller. And see if I can make it 6 fixed. Man, it's hard. I'm going to start 5.8. Not bad. Then I'm going to say how far is from the center of a circle. I'm going to connect it to the center of a circle. And I said that is J. And what is that distance right here? 9.18. When I subtract these two numbers, let me see if I can find a better number for these 9.18 and 5.8 by moving that circle. Well, come on, man, make it 4, please. Okay, assume it's 4. The difference between these two is 2.86. Remember, 2.86. Okay, then what I'm going to do, I'm going to move that point, and I'm going to say, what happened if we come on the other branches? 2.86, here 2.86, here 2.86, here 2.86. Oh, the difference of these two distances is always a fixed number. Is always 2.6 for that specific graph. And I don't know where did I make a mistake that I end up with 2 branches. Someplace I messed up about my trace. Because I have because I changed my circle, and because I changed my circle, that become 2 branches. Therefore, when I subtract this one, 18 from 02, and that's 2.5, it still is 2.86. Okay, do you see what 8.6? What does it mean? Means that point E, you have an airplane right there. That airplane travels from Dallas-Fort Worth to Washington Dulles Airport. But when it take off, at any given time, it's going to be in one of those branches. Therefore, when it communicate to these two airports. And if the plane get in trouble, who can hear the pilot first? The one is closest. But you know the speed of a sound. And this airport, air traffic controller, are going to call this one because they are connected with each other with a wire. There is no difference in time. And these people are going to say, oh, I just heard him. They know the difference time. They know the speed of the what? The speed of the, tell me what I'm trying to say, speed of the sound. And they can find the location of the plane if it has a problem. But what is that fixed distance? I want you very quickly, I'm going to go in here very quickly. Do you see this one right here? That's the vertex for that problem. And that vertex is for that problem. I'm hoping this is a vertex. And if I connect these two vertices together, oh, I bet you $100 that distance is exactly 2.16. But in here, I didn't get 2.16 because I messed up my E and I messed up my point in here because these are pictures. And therefore, you have to know the distance from E to this focal point and distance to a further focal point. If you subtract them, you always get the distance between the two vertices. Therefore, hyperbola talk about differences. Ellipse was the sum. That's the reason ellipse has a plus sign between x and y, and hyperbola has a negative. Then let's go back right here and prove it and see what is the equation of a hyperbola. Okay, I'm gonna say, in order to make my life easy, I'm gonna say this is the middle of the two vertices. One vertex is here, another vertex is here. Therefore, I'm going to have two hyperbola, two branches of the graph. Hyperbola, we had two branches. But because this goes to infinity, I need an asymptote. And in here, I need also an asymptote. This distance is A. But remember, the two asymptote is going to be the diagonal of a rectangle, please. See, that's exactly the diagonal of these two. Therefore, if this is A, I call this length is B. But please remember that your C, the focal point is here because this is a vertex. Therefore, in an ellipse, your C was less than an A. But in here, your C is bigger than an A. Over here, A was a hypotenuse, B, which was a major axis, B was a minor axis, and C was the distance from a center to a focal point. Therefore, the Pythagorean theorem was really A squared equal to B squared plus C squared. Therefore, it was a relationship between the foci, the minor axis, and the major axis. But in here, this distance right here is exactly that distance. Therefore, this is C. Therefore, if this is A, this is B, this is C, the relationship between the foci, the major axis and the minor axis, in here I cannot really call it a major axis and a minor axis. I call it major axis and a conjugate axis, not minor, conjugate. Sometimes the conjugate, the B is bigger. It depends how your rectangle is going to look like. Therefore, you have to be very careful when you're talking about those asymptotes and you're talking about in ellipse, you talk about the major axis and the minor axis, but when you're talking about the hyperbola is going to be different. Therefore, in hyperbola, we have conjugate axis, and the A is a distance between the center to the vertex. Okay, let's make it neat and clean. This is the vertex. This is my B. You can make it taller or shorter. That's my B. This A and that A are symmetric. B and B is symmetric. Therefore, what you do, you create a box right here. That's going to give you the two asymptotes right here. And this is the vertex that fall toward the asymptote, and foci is here. Do you remember on that graph? The foci was right here, and these are the vertices. Therefore, center of a circle was one of the foci. The point you pick outside the circle was another foci. Therefore, any points on the hyperbola, the distance to this foci and this foci, when you subtract them, you get them the distance between the two vertices. Then in here, I'm going to say this is A, this is B, and this is exactly that distance. Because remember, this is a slant. And a slant, the projection is here. But when you talk about hyperbola, the relationship between the axis, the conjugate axis, and the foci is exactly look like a Pythagorean theorem. Okay, somebody said, what is the equation of an asymptote? This is the center of the hyperbola. Maybe the center is as h and a k. Therefore, equation of asymptote is y minus a y1 equal to mx minus a x1. M is the slope, y1 is a k, x1 is h. But what is the slope? The slope is easy, right there. B over A. B over A. But somebody said, how about that one? B over a negative A. That becomes a plus minus. This one is for the B on the top and A is on the bottom if the parabola is faces to right and left. And if the parabola go up and down, this is A and this is B now. And that's make it, A over B instead of B over A. It depends how this hyperbola is situated. Okay, then you have some idea. Let's find the equation. And I'm not going to do all of it. I'm going to do some of it, but hopefully you open your textbook from pre-calculus and study. This is your A and 0. This is negative A and 0. I'm going to say this is B, 0 and a B, and this is 0 and a negative B. This is my rectangle. These are my asymptote. This is my hyperbola. This is my hyperbola. This is my F1, which is C and 0. I call that distance as C, and that's the negative C and a 0. And what did he say? Wherever the plane is, the distance between to this air traffic controller and this, when you subtract that distance, you should get that one. Therefore, if from here to here is a, this is also a, the whole distance is 2a. Therefore, I'm going to consider that point x and a y. I'm going to find that distance. I'm going to find that distance, subtract them, and set them equal to 2a. Give me that distance. X minus c squared plus y squared, because here the y is 0. What is that distance? Is x minus a negative c squared plus y minus 0 squared. Somebody said, which one I have to write first? Remember, the distance, in order to be a positive, the one you write the largest, that's the negative one. But somebody said, could I do other way around? No, you have to put the largest minus the smallest equal to 2a. And how do we solve equation containing radical? We do exactly like we did with ellipse. We keep the most difficult radical in one side, and that becomes x plus c squared plus y squared, and take the other radical to other side, but because it's a negative, become a positive plus 2a, and you square both sides. When you square it, it becomes x squared plus 2cx plus c squared plus y squared. What is the other side? When you square that one, it becomes x squared minus 2cx plus c squared plus y squared. That's the whole thing when you square it. You have to double the product of these two. Double, make it 4a times, my computer is running out of a battery, and 4a x minus c squared plus y squared plus 4a squared. See, that x squared and that x squared is gone. The c and a c is gone. The y and a y is gone. You have negative 2cx is 2cx. It becomes 4cx. This is a constant. It come to other side, become plus minus 4a squared. That radical be all by itself. By itself, I'm going to keep it on the other side for the heck of the what? To get rid of it by squaring it. This coefficient is 4. I divided by 4. That's make it easy. Right now, we're going to square both sides. When I square both sides, that become a squared times x squared minus 2cx plus c squared plus y squared. When I square that side, it becomes c squared x squared minus double 2cx a squared plus a to the power of 4. This is ax squared minus 2cx a squared plus a squared c squared plus a squared y squared. Okay. Oh, that's the ugliest piece. They cancel out. Then what I have left, I have x squared here. But remember, I have ax squared here, cx squared here. I'm going to put c minus a squared. And that should be a squared. I brought it to the other side, factor the x squared. This is a squared y squared. I'm going to bring it to other side. Everything doesn't have x and y, and move it to other side. This is a to the power of 4, and that's a squared c squared. I took care of everything else. A squared c squared minus a to the power of 4. A factor a squared is c squared minus a squared, and I'm done. And what did he say a few minutes ago? The relationship between a and a b and a c, which is a focal point, is exactly a squared plus b squared equal to c squared. And what is c squared minus a squared? Is b squared. Then in here, instead of that one, I put b squared. Here, I put b squared. What is left? X squared over b squared minus a squared y squared equal, x squared b squared, not over, equal to a squared b squared. If I divided everything by a squared, b squared, the b squared and b squared canceled, you have x squared over a squared. And if I divided this one by this, a squared and a squared is canceled, and is y squared over b squared equal to 1. Do you see the ellipse was a plus and this is a negative? Therefore, here we see the difference of two distances are fixed. Over there we said the sum. Therefore, from today, you have to know this from this equation of the conic section. Ax squared plus bx squared plus cx plus dy plus f equal to 0. If a become equal to b and both their product become positive, either both positive or both negative. If both negative, you divided them by negative. If both are positive, I'm okay. That become a circle. When a and b are the same, this is your a, this is your b. A and b is the same. A and b call r, radius, and that become a circle. But if a is not equal to b, but the product is positive, remember ellipse is the same as what? We said this is part of ellipse. I'm sorry, this is a special kind of ellipse. But on the circle, the major axis, minor axis are exactly same, but the ellipse, the major axis, minor axis are different. Therefore, if A is not equal to B, but both are positive, is an ellipse. But what happens if A becomes 0 or B becomes 0? If one of them becomes 0, this is a y square. If one of them becomes 0, therefore you have two y-intercept and one x-intercept. Two y-intercept and one x parabola. Sometimes b is 0. If b is 0, you have two x-intercept, one y-intercept is a parabola. And this is a parabola. But if a equal to b or a not equal to b, it doesn't matter, because on hyperbola you can have your a very small and b large, or a and b could be the same, or b could become bigger. It depends how you put your rectangles. That's your choice. Therefore, a could become equal to b or a not equal to b, but one of them has to be negative. If the product is negative, that's called hyperbola. Therefore, product negative, a equal to b or a not equal to b, that become a hyperbola. I mean, this has to be a positive, this has to be a negative. Or this be negative, this be positive. But if both are negative, circle. And AB should be the same. Both positive, AB the same, are circle. But if one becomes 0, 2 intersection and 1, that become a parabola. But if A and B are different, therefore you have elongated circle, but A and B must be positive. This is your review of the conic section. I hope you understand the definition of it. With the best of luck with you all, and have a great day.